a lot of opportunity for you guys to participate. Um, I'm actually planning to have each one of you present some of your code in class um, as you are doing it. Starting today, we are going to have every day, every lecture. After every lecture, we'll have a quiz. Okay, the quiz is very simple. It's basically just going to be you write a small program. Okay, that's all you do. All right. The quiz itself is not graded. Okay, so we're not going to judge you for wrong or right with respect to the algorithm you implement, the code you write. The purpose of that quiz, number one, I need to track whether you're in class or not, right? Because so the CS department now require us to be able to provide a date when you guys drop the class. The date you stop showing up in my quiz, I know that's the date you disappear from my class. Okay, that's one thing. That's a procedural thing, practical things to do. However, the main purpose of you participate in the class is to be able to develop software systems. That's our goal. And guess what? The main job in developing a software system is actually to write code. All right, that will be your job to come at least for the first several years of your career, right? Then it's also the doorway for you guys to get into a good job. So that's our focus. We are going to actually spend a good deal of time on coding. So there are several components that say walk through the syllabus you will see. We will give you plenty of opportunity to actually to write code. So the main thing for us in this class is to scale up your capability of writing code. All right. So you have all been through 161, 162, and lower level programming classes. When you are provided with programming templates, you complete the templates, you get your grade. All right. From here on, you will be trained to write program from ground up, basically without anything to start with. Okay. So you probably have been comfortable writing 100 lines of code at this moment. We would like to move that to thousands of lines of code. Okay, that's the main goal for this class. Some of you may actually already have the skill set already, but to pass my class, you have to demonstrate your skill set. Okay, that's fine. I mean, so if you think, oh, I can already write 5,000 lines of code without any problem, yeah, you have to demonstrate you are able to do that. Okay, our goal is that when you guys graduate from my class, you are comfortable with just by yourself, starting with almost nothing, write a couple of thousand lines of code, and say, yeah, I'm good with that. That's the level you can actually get a job in industry as an intern and claim that you can write code. Okay, a couple hundred lines of code would not do it. Okay, we're going to scale up to 1,000 to 2,000 lines of code, and as you progress through our program. Once you get to Capstone and CS 554, 454 for undergrads, you are looking at, as a team, you work out, 5,000 lines of code. Okay, so that is basically the level of coding expectation in industry anyway. If you look at the industry coding, you write a lot of code for sure, but eventually the amount of code you actually check in the repository a year is roughly 1,000 or 2,000 lines of code, or even a little bit bigger than that. You're not going to be able to check in like 500,000 lines of code each year, right? You probably write 500,000 lines of code because you have to write a lot of code to get the right code and a lot of code to debug and test, but you're not going to be able to check them all in, okay? The thing that really counts for you are going to be the code that check into a repository, okay? That's how actually a lot of companies measure your productivity and progress, right? For instance, in Google, whenever you up for promotion, if you are going to be up for promotion as a software engineer, as a developer, you basically have to point into their internal repository and say, okay, see, that's the code I contribute. This is how much I contribute, how many bugs I fixed, right? How much code I reviewed for other people. And this is repository should look at my contribution and my productivity. Okay, that's an objective measure a lot of people use. And now, also nowadays, actually, before somebody got hired, they actually, some of your future employers actually look at your repository on GitHub and what have you, and see what kind of code you have done so far, right? Say if you have the capability of already show that you can code a couple of thousand lines of code, put that on the repository and you are confident enough to show, that's a very good indicator that you are capable of doing that. No better proof than that, all right? So programming is going to be a heavy focus of our class. So I'm not going to teach you how to crack all the grammars, but we'll provide you plenty of opportunity to practice. Again, come back to our quiz. Certainly, it's a attendance requirement for sure. On the other hand, since we have a smaller class, finally we have a smaller class this term. Used to be I have the full class, and we couldn't do this. So each time we'll have about 18 quizzes. We have about roughly that many students in our class. So for each quiz, I'll ask one of you come here and write your code on the whiteboard. Okay, so that's exactly the reason why I'm saying we're not going to grade your quiz. I mean, assign credit to it in ways to say, okay, whether it's wrong or not. So your participation will basically give you the credit for the quiz. The quiz is for class participation only. But it's an opportunity for you to write code. The rest of you today, probably you don't have your computer with you. And next time you do want to bring your computer with you, because we're going to write code on computer, not on piece of paper. I mean, if you can write code on a piece of paper, it doesn't mean that you can write code on computer. Okay. So we'll
I
have.
don't actually own a laptop,
Okay.
so I can't bring one.
That's okay.
I have one at home I can bring in for you.
No, it's all right. So if you have a pad, that's good enough. That's good enough. So we're basically just going to code into a website, so you will be able to submit your code.
Okay.
Yeah. So it's owning a laptop is not a direct requirement. Actually, I have plenty of students just code on their phone last term. That's okay if you prefer that, but I think a pad would be sufficient. All right. All right. So it's going to be. So I'm not trying to scare you guys away, but the key thing is programming is going to be a core for software engineering. Without that, you are basically just your job opening are just going to be project manager and product manager and marketing people and so forth. You're not really in the core of software development. In the core of software development, you have to write code. You have to be able to test and debug code. That's our central requirement. That is also the focus of this class. Okay? All right, let's run through our syllabus. So essentially, here the goal is it's not going to be like the template-based programming you guys have seen. You know exactly, they will tell you exactly what the functionality of the program you should be writing. Okay? Yeah, that's nice, but if you think about it, when you get to your job, that's not going to be the case. Nobody's going to set up the template for you to code into it. You have to basically code to solve a real problem. Okay? So that's why I'm saying it's going to be from problem specification all the way through design, implementation, testing, and maintenance. Actually, that's going to be the 5 activities we talked 1,000 times in this class. What exactly is specification? So this is like your mom telling you, okay, I need you to create a spreadsheet for me, which can automatically calculate my monthly spending. How many of you think you can do that? That should be 100%, okay? Because you basically add up a few numbers and that's it. However, there is no template, right? Your mom is not going to give you a template. My mom didn't give me that, right? She's just going to demand what needs to be done, right? That's my first example for your specification. Somebody will provide you a demand and say you do this. You say, oh, I'm not doing it. Yeah, you can say that, but if they pay you, then you better do it, right? Once you get the job, your manager say, go do this. You say, oh, I'm not going to do it. Yeah, that's not how it works at jobs, right? So that's what happened at PSU, but not in your job, right? So in that sense, we're going to go from something, basically you can think about it as your English specification of something, and you have to translate that into perfectly working code. That is actually the mission of a software engineer. No other things. You can hear all the buzzwords about machine learning and AI and all this good stuff. I mean, in the end, it's translate your job as a software engineer is to translate spec in natural language into working computer code. No exception. You may say AI is great, but somebody need to code that AI system up from nothing to into the working system. Then you can use. Yeah, some software engineer have done the job. Okay. Then you may. So what exactly is design? All right. So for instance, I now gave you say, oh, you need to help your mom tally up all the spending. She had this month. Whenever she purchased anything, she will enter something in the in a form, HTML form or something. Then by the end of the month, she push a button. Then everything got added up, tied together, and also all the nice things. You have in your bank account and also all the bank card. You have that functionality, right? So then you have to ask the next question. Okay, I do have something in English spec. That's something I need to do. But how exactly I'm going to do this? Some of you directly go into coding. I'm just going to code, and hopefully I will find the answer, right? But at least you have to think about what will be in your software programs, right? How many modules? What modules? How they work together to solve the problem. Certainly for the example I just gave you, you don't really need many fancy modules. You probably just need one module, and that will be it, right? However, if I give you a much more complex project, okay, not only I want you to calculate the current spending, I want you to be able to query her bank account to find out whether she has money money for that kind of spending, or can make plan for the future, and I can add all kind of functionality to it, right? Then you have to think about design is really defining the structure of the program you're going to write. That's the job somebody has done for you in terms of providing you the templates. Okay? So now that person disappeared. Okay? Back in 162, 161, you have that person, that's your grader and TA and your and so forth. Now that person disappeared. Okay? So you have to set up the program structure yourself now. Okay? That is our design stage, in a nutshell. Okay? Implementation going to be pretty straightforward. You write Java code, Python script, C++ code, C code. You really code the functionality of all these modules. Okay? But once you're done, how do you know you're right with the program? I mean, given that you already got it compiled, that's not an easy job, as you guys found out before. I mean, when you write some code, I mean, it just doesn't compile, right? But I hope you have passed that stage. I don't have to debug for you on compiling error, right? Then you are really moving into testing, which is you have to demonstrate to your mom your program actually works. Right? How? That is our testing process. Before you go show your mom, it's probably a good idea that you test that program yourself and show to yourself it actually works, right? If I go to my mom and show something that's totally not working, I mean, she will be really mad, right? So you probably have to do something as testing for yourself. Actually, that's your in industry. That's also your testing process, your alpha testing, so forth. Basically, you're doing integration, you're doing unit testing, you're doing alpha testing. Basically, you are testing that for yourself to be sure your program actually works. Okay. Once you move on, you're going to deliver this product to your mom. Then you probably have to do a round of beta testing, which is get your mom trying that, and you watch and see if something breaks. Okay? If that doesn't break, great. You're happy, your mom is happy, then you deliver the code to her and say, okay, this is your program to use for the years to come. Okay? Certainly, she loves the program, she wants more features from you, then hey, guess what? We are getting into the maintenance stage of our program. Okay? So that'll be the 5 components we'll discuss many times. Okay? However, the crux of this is really for you to take a piece of English spec and convert that into a real working program. Who will give you that spec? That's a different story, right? For instance, the people who are running the business, starting up a company, their job is to cook up that demand. And for you as a software engineer, you are solving a problem with software programs. Basically, when they provide a demand, you satisfy that demand with your code. That's your job. Okay? So if you want to learn that part, how to come up with the demand, you probably have to go to business school and see how they cook up all the stories to make money. Right? It's our job basically to say, okay, we have a demand. We want to solve this problem through coding. Okay? Don't make too fancy about this. Your job is actually to write a problem to solve somebody else's problem. Write programs to solve somebody else's problem. Okay? So we're going to look at how we collect specification, how we do design, how we implement, how we test, and how we maintain a software program. You may say, oh, maintenance sounds really boring, right? I'm done with the program. Why do I still touch my program? Yeah, I never touch my program after I'm done with your class, right? Yeah, because you're not making any money out of the program you write for me. If you're writing a program that's making money for you, you better hope that your user is demanding you to make changes. Actually, 75% of all the money in software industry comes from maintenance, which is basically you put a program out there, you'll be glad to see people using it and continuously demanding you adding new features. If you put a program out there and nobody even touch it, you know the fate of the program. Okay? So there is a disconnect between write a program for an instructor like me and write a program for real customer. Write a program for me is really just write once and never touch it. Okay, because your only goal is to demonstrate you have the skill set and can graduate from my class, hopefully get an A from my class, right? That's your goal. After that, you say, oh, bye-bye, I will never touch this program, I hate this program, it should disappear from my life. But that's not the case in real software development. Okay, if you imagine Facebook just writes once a throwaway, what will happen? Actually, Facebook is there, keep asking you for things, right? Oh, come on, come back, right? You haven't come to the site for like the last 7 days. You have missed a lot of good things about your friends. Oh, come back, right? They need you to come back because you are their customer, they need to steal your information, so they have to have you come back all the time, right? So essentially that's all the good part about software engineering, right? So we are solving somebody else's problem. Eventually, you hope that this demand coming back, because if they are not coming back, there's only one end to that program, which is disappear. Nobody touch it again, has basically zero value. And you certainly don't want your work to have zero value, which is not going to make you any money. I mean, not going to, even if you're just doing it for fun, it's not going to bring any fun to you. Okay? All right, so that's our course objective. Basically, have you write more code, and to scale up from a couple hundred line of code to a couple thousand line of code, right? That's when you can go into all the major computer science classes with confidence, and when you graduate, we hope you can work as a team to be able to deliver, 5,000 line of code with ease. That's basically is the typical capstone project you guys will get into. Okay, if you can do that, yeah, finding a job should be easy for you. There are plenty of demand for you who are able to write code. Okay, then later on, when you're tired of writing all the code, you can move up through the code food chain all the way from implementation to design, which when you become a software architect, you are basically dishing out work for somebody else to implement. That's what software architect is about. Okay, take a major specification, a big chunk of specification, draw up all the module structure and dishing out the work for people to complete and get it back and assemble together. That's your product. Okay, that's your. If you have a job as a software architect, then you can move up even more to the requirement stage. I mean, that's basically when you become a product manager. Okay, for instance, if you're running one feature for Twitter, okay, you are basically saying, I need this feature, and you talk to a software architect and say, I have this feature need to be implemented. You go